In this video, we're going to take a look at how we can use our assembly, which should operate like this, with the follower following the cam. We're going to use this to generate a motion graph for the cam. And if you'll recall, a motion graph is defined as the height of the follower as a function of the angle of rotation of the cam. So the way we're going to do this is as follows. We are going to create a angle constraint, directed angle constraint, between the plane here, the work plane for the cam, and some exterior surface like that. And if we cancel there, then we find that we've lined those two things up, but unfortunately our system doesn't turn. If we do want to turn that, we can go to, I think it's this one down here, is the constraint in question, and I would like to rename that. It keeps asking me if I want to, there we go. I'm going to call this user angle, because we're going to be manipulating that angle. First way we're going to do it is we're going to drive it through, let's just do it once around, from 0 to 360. And it's kind of nice to be able to show, say, your customer, if you're making this for a customer, of just how it works, and it's rather satisfying to see that. That's one use of that constraint that we just added. The other one is to actually determine the motion graph, and to do that, what we're going to do is we're going to start out with a worksheet in Google Sheets, and we're going to, along the x-axis, we can say angle of rotation in degrees. And here we're going to say hex cam height. How's that? height. And that's going to be in inches. So we're going to populate these two columns down through here, and we're going to then generate a graph showing how the height varies with the angle of rotation. So to do that, let's go to our assembly, and we're going to use the on the sketch tab, inspect tab, we have distance, and you want to have that top of cam work plane visible. So we click there, and then we click on the top of the box, and we get 3.514. So that height is 3.514, and the angle of my user angle is 0 degrees. We just arbitrarily define this as 0 degrees. No harm in that. It's going to be repeating motion, so that's 0 degrees here. And we can come and we can make these a little more, look a little better by centering those. Maybe we make the header bold. Okay, so then we're going to come to here, and we're going to close this. It's a little tedious. Okay. And we're going to change this to 30 degrees. Now, as I hit enter, watch the cam rotate 30 degrees. And you can see it goes up to really its maximum at this point. And we're going to again choose the distance tool, here to here, 3.715. So that was 30 degrees here, 3.715. Okay. Let's go back and put in 60 degrees. So we're going to go to 0 to 360 in 30 degree increments. So 30 degrees, 60 here. Enter. And you can see we're back at here, whereas same place we were at 0 degrees, so that we can use that to reduce a little bit of work for the hex cam. And that's again 3.514 as you might expect, since we were on a flat of the hex cam at 0 degrees. So at 60 we're going to get 3.514 again. Now hopefully I can convince you that as I go to 90 degrees here, so let's just put these in 90. One thing you can also do here is equals the previous one plus 30. And then you can drag this down and it will populate it. And we got what, a few more, one more. So you can use a formula to populate those, save you some work. Hopefully it's clear that we're going to go from 3.514 to 3.715 over and over again, just due to the way a regular hexagon behaves. So if I hit 90 here, it's going to go to the maximum height like that. So if that's the case, then I know that the next one's going to be this one here. Control C, Control V, and basically I can just take these two values and keep propagating them down. And the last one would be, let's see, this one, because 360 is the same physically as 0. Okay, so once we have that, and by the way, when you do this for the eccentric cam or the pair cam or the spiral cam, there's not as much symmetry, so you can't really get away with doing what we just did there. You really need to go through and do each one individually. So to make a graph, we're going to grab the data with the mouse, insert chart. It's going to pick a chart for us that it thinks is the best, and this is a pretty good one. The one change I'd like for you to make on the Customize tab up here, go to the vertical axis, actually go to chart style, and let's just, is it chart style? Let's go to the data tab. No, where was it? Chart style. I think I need to grab it here. Yeah, so grab the chart and it'll have chart type. So let's go down to this one here, smooth line chart. So it just makes it a little smoother. We know that's more what it's going to look like. And so there you have it. We're done there. We're not going to worry too much about the good chart hygiene at this point, but I am going to come to the legend and I'm going to turn it off because we only have one thing we're plotting here. So you can see that the height of it says hex cam height. I'm going to say hex cam. This really should say follower. And I'm going to try to edit here too. And I have to come over here, hex follower. Hex cam follower. Okay. And then I think we can just close that part, and we've got a graph here which shows from 0 to 360 how the hex cam, the follower following the hex cam, will go up and down, up and down. So it seems like it's really doing some shaking there. One thing to keep in mind though is the maximum distance that is being moved, and you can see 3.7-ish here, 3.55 here, not very much. One way to show that is to go to the vertical axis and put in 0 for the minimum value. You can see that it's got a high frequency of oscillation up and down, but it's very low amplitude, or relatively low amplitude it seems. and we'll eventually compare this to the other ones, other cams. So that is how you make a motion graph for a cam. You'll do the exact same things for the other types of cams, and again, you won't be able to get away with just copy and paste like I did here. You'll need to go through 0 to 360 and do them one by one due to the lack of symmetry or less symmetry in those other cams. Thanks for watching.